Today, we're doing our training Tuesday from basically where we all go to learn, a school. I'm in Stephenville, Texas. Due to the pandemic and social distancing and things like that, I have had to rearrange where I am on a daily basis, and it's got me back home in Texas with my family. And so the school in Stephenville, the local school, blessed me with the ability to come in and teach you guys from their local school. So join me in our class as we learn Training Tuesday and do an AIA accredited course over access. If you have any questions, please let me know. I'll stop intermittently and allow you guys to ask questions. But as stated earlier, this is an AIA accredited course. And so with that being said, we do allow you guys to gain CEU credits. But if you will, please send me an email with your AIA number, and we'll make sure to get you a certificate of completion for the class today. We have about 40 slides going on, so this will take about, I'm going to say about 40 to 45 minutes. Bear with me. Some of them will be a little bit long, but this is a basic intro to electrified hardware, and it also gives a little bit of an intro to mechanical access control as well. So with that being said, let's begin. There are a couple slides that I have to read, so I apologize. Today, what we're going to do is we're going to learn some of the basics of access control systems, the different types of access control, going from mechanical access control, hardwired access control, and then wireless access control. We're not going to dive into each little bitty part, piece, and component, but we are going to do a broad scope of access control. We're going to talk about how access control works, what is used to make each one of the components work, electricity, or whether it's mechanical push button, or if it's mechanical with use of a key. Then we're going to talk about some of the codes and standards that are related to the access control. So here we see a security continuum. And as you can see, we're going to start with the basics at the bottom, and then I'll move all the way up to enterprise level solutions of access control. So at the bottom, we have mechanical access control. That doesn't mean that it's the least secure of access control. It just means that there are limitations, and with mechanical access control, there are the most limitations, such as audit control, reading who is and is not inside the building, limiting access to parties after they've either been fired from work or lost a key, things like that. Then we move into electronic access control products. This can be battery operated, standalone access control, and it could also mean hardwired access control. But there's a whole new tier of networked access control products which are only hardwired in. Now, this could be products that have a low-tier head-in software, such as Keystone Luna, which is an economical solution. But then we jump into enterprise-level solutions where you have multiple sites running off of one software, and you have the ability to do multiple site lockdown and things such as that. So why do we have access control? Maybe some mechanical locking limitations to provide a higher level of security, provide an audit trail. As we discussed just a little while ago, with mechanical access control, you do not have the ability for an audit trail. You also do not have the ability to monitor the opening. With electronic access control, however, you can monitor the opening. You can decrease security personnel, increase efficiency of the opening, and it's just convenient. Having the ability to use a mobile credential or a key fob to gain access to a building is a whole lot more convenient than having a big roll of keys and trying to fumble through which key works which lock. So here are some mechanical access control solutions. As we can see, we have exit devices, deadlocks, padlocks, cam locks, small format IC cores, and then regular cylindrical locks and cylindrical deadbolts. There is nothing wrong with mechanical access control, and mechanical access control, if we want to get serious, is the most secure, because if you do not have a key, you cannot gain entry. If you do not have electricity in a building, you cannot gain entry. But there are limitations. Some of those limitations that you find, if you lose your key, folks have the ability to duplicate that key, put it back where you left it, and then they now have the same credential that you have. Same goes with a proximity reader, a proximity card. Prox is so unsecure now that we have the ability to scan your card and duplicate it within a matter of 7 seconds. Another limitation is the lack of an audit trail. Because it is mechanical and it does not have any electricity going through it, there is a major lack of audit trail there. And what the audit trail is finding out who has been in and out of a room at any given time. You have another major limitation, especially if you're in a school such as where I am today, and that is lockdown feature. You do not have the ability to lock down the perimeter of your school or restaurant or office building if there is a threat that is imposed. And then lastly, you cannot check the door status if the door is left open, if it's closed but it's not latched, if it is latched but it's not locked. You don't have the ability to check on the health of that opening, because there's no electricity going to the opening, there's no software that's controlling it. Because of that, they started to create different ways to start to protect your mechanical access control systems or your keys and your locks. And they created key control software, having the ability to keep records of how an opening was keyed or how it was bitted, how it was pinned. Also gives you the ability to show how or who you distributed keys to. So it created another way for us to start controlling or managing different personnel and different people that were going in and out of a room. So then, after knowing that there was limitations with mechanical access control and mechanical software, I think it's called like Keystone Software, we took it up another level, and we made electronic hardware, electrified hardware. Electrified hardware is basically mechanical hardware that has a solenoid or a motor drive that's built into the device, and it allows it to, it creates that mechanical function by way of electricity. And as the slide says, mechanical hardware that uses electricity to accomplish mechanical motion monitoring or other access control purposes. By adding electricity to lock sets, we then needed a way to start managing those lock sets, start monitoring who's going in and out of rooms, start to issue badges and things like that. So we needed head-end software or an access control system. Some of the most common that are out there are Linnell-based. There are some others, such as Aurora, Keyscan Luna, things like that. But once we started to create this, we gained the ability to add audit trail, dispense keys on a real-time basis, and then eventually start monitoring doors and openings, whether they be sliding or swinging doors. Who's going in and out of those rooms, and things like that. And we could also track where a card is throughout a facility. some access control options that came out were battery operated, hardwired, and wireless. The most economical access control hardware is battery operated or standalone hardware. The one limitation, the major limitation to battery operated hardware, being that it's standalone, is there is no real-time audit of that opening. You have the ability to give a person a credential or give them a combination, that they can push in, but you cannot truly monitor who's going in and out of that opening. So to get around that, we started to do hardwired systems. When you use a hardwired system, it is more expensive. You have to run wires, you have the labor to pull that wire, you have to connect it through the door, you have different preps and things like that all have to be accounted for. And when you account for all that, you do gain the ability to monitor the opening, monitor if the door is open and closed, the audit trail, which is the most important part. And if you're in a school, the ability to lock down the facility. Through technology and things, we were able to create wireless solutions by way of a gateway, using a gateway instead of a ISC. We were able to create the same functions of a hardwired system with the audit trail, with the ability to lock down and the ability to monitor the opening. Offline systems or standalone systems, they're battery operated. The programming is done at the door by way of a laptop or I think there's a handheld Palm device. And, one of the major takeaways from it is there's no lockdown capabilities. If you have a card or if you have a combination, you have the ability to gain access to that opening. And there's another major limitation is you always have to have a member of staff available to go on site with their laptop or their Palm in the event that there's lost or stolen cards, if they need to change users, if they need to deny users, things like that, or if they need to have a audit of that opening, a staff member has to go to that opening and perform that at the door. So online systems, hardwired systems, and this is a small diagram of a hardwired system. You have the ability to hardwire directly to the server from the access control panel or the access panel to your reader, to your door sensor, to your lock, and have the ability to monitor and watch that opening in real time. So the system components are physically wired to the control panel. The programming is done at the desktop with head-end software. So software such as Aurora and things like that gives you the ability to program your components or your readers, and you can in real time lock down an opening, change users, and audit that opening. You can have activity reports that are available to the user on a real-time basis and real-time data transfer. So like I was saying, if you have to change users and things like that on the fly, if someone is fired and you don't want them to have access to a sensitive area, you can cut them out instantly. So if we were installing, I'm going to go ahead and take care of this question for you, Naveed. If we were installing a access control system in an existing door, I would really suggest finding out what the system is needing to do. If you have to have that real-time audit, if you have to have that real-time activity report, if you have to have lockdown features and things like that, we would then move into seeing, will a standalone product work for you? And as you say right there, Naveed, real-time audit is needed. I would definitely move to a wireless system, especially since it is an existing opening. You know, you have to, if you were doing a hardwired, you'd have to go through the frame, you'd have to go through the door, which would cause complications trying to pull that wire. But if you used a wireless setup, I think that you would be able to do that with a wireless gateway, interacting wirelessly via Wi-Fi to your router, connecting to your lock set. I think it can be accomplished really quickly. Let's talk offline, and I can give you some products that would help out that I cannot mention in an AIA course. So as I was talking with Naveed about, a wireless solution, by using a portal gateway, you're able to communicate with a lock set wirelessly to gain that real-time audit, to gain that real-time lockdown, and also to gain the ability to change users from your host in real time. The benefits of this is having no conduit for the power or the data at the doors, the wiring, wiring to transmitters. The programming is at the desktop or at the host computer with the head-end software such as Aurora and some other types of software that's out there. And sorry, I'm the most familiar with that one, so I'm going to mention it quite a bit. Data transfer can have latency, so there is, it's not real time, but with some of the products that are out there that I could mention to you, Naveed, offline, there are some that are out there that are nearly real time. And so there also is, depending on beacon time, there's some delayed programming. So beacon time would be when the lock set is communicating back to the gateway, which communicates back to the host. What's the differences between hardwired and wireless? Well, the major difference between the two is the wiring. As you can see in the left-hand photo, your door sensor has to be wired back to your ISC. Your AC power from your power supply has to be wired back. The card reader has to be wired back, and then the door strike has to be wired back. And then all of this has to be wired back to, to your server to be able to work together, your power supply, your server, and things like that. With the standalone option, and this one that's being shown is the YQ solution, everything is at the door. If you wanted a card reader, if you wanted push button, if you wanted a door status sensor or latch bolt monitor, all of it is right there at the door. The labor cost between the two, or the differences between the two, is insurmountable. So whenever you remove the labor of pulling that wire, the wire cost itself, a wireless solution is a lot easier on the bank and a lot easier for your customer. And honestly, aesthetically, it's going to be a lot easier as well. So what are some of the differences between standalone and wireless? Because standalone is a wireless solution, it uses batteries, but it doesn't communicate with a gateway. The major difference is no audit trail. The programming has to be done at the door. Whenever you take away the ability to have Wi-Fi in the gateway and the communication between head-end software, you take away all of that from your lock set. So by having a wireless lock, which is battery operated, by the way, but a wireless lock that communicates with a gateway, you can communicate remotely. You can perform an audit trail. You can make changes in real time. You don't have to carry around a laptop or any of that bulky material that, honestly, in our time now, we don't want to carry around any of that, any of that hardware. But there are benefits of mixing technologies. Maybe you do want to have a hardwired solution at the exterior, so that way you have real-time lockdown in the event of a shooter situation or a panic situation. Maybe you do want to have the ability to have real-time auditing and real-time changes that without any latency. If you're in a new build, maybe a hardwired solution at the exterior is the best solution for you. By mixing technologies, you can still use less wiring and less wire runs because you're just going to the exteriors of the facility. And then by mixing standalone units at areas that doesn't need audit trails, or if you want to have a wireless technology at some of the interior doors to where customers that are using a key fob to get into the exterior would also want to use that same key fob to get in through the interior doors, you have the ability to do that. By mixing technologies, it's more efficient. You reduce costs that are allowed by the facility, and you add more access control. Because you have more money to spend, you're able to put more doors on the system. So how does it work? It's very simple. All you need is a power source, conduit, a load or a lock, and a switch. Just like a light switch at home, if you can flip a switch on and off to turn on a light bulb, and you understand how that wire run works, you can do access control. I don't want to dismiss the intricacies of access control, but that's about as basic as it gets. So we have a person or identifier, which is your key card, code, or biometrics reader, or keypad. You have your controller, which is the brain, which is your ISC, your control panel, and then you have your output device, which is the means of programming and communication. We have software. Earlier I discussed Luna and also Aurora. We have electronic locking devices. This could be a motorized lateral traction exit device. It could be a solenoid-driven lock set. It could be door position switches, request exits, door enunciators. So here is the bare bones basics of how it all works. We have the host, which is your workstation or server where your head-end software is installed. You have your control panel, which is the brain of the whole thing, the whole unit, which tells your, which has the reader interface installed inside of it. The reader interface tells the reader or the locking device. It takes information to and from the reader and then to and from the locking device to say, yes, I did see those eyes before, which is in this instance an infrared reader, or yes, I have seen this guy before. I scanned his face and he does look like the person that I let in earlier. They'll then send a signal to the locking device saying he is okay to enter the facility. All of that is programmed and stored at the workstation here or at the server. Architecture at a high level. So we have the ISC, which earlier we discussed is the brain of the operation. We have the server, which holds your head-end software. This is going to have all your programming and things like that stored into it. Then we have our network, which if you're using, multiple types of technology, you could have some hooked to a gateway and some hooked to the ISC or hardwired in. We have our reader interface, which again is inside the control panel. And then we have our lock sets. So as you can see here, we have our card reader, which is going to communicate to the reader interface. It's going to send a signal through the network, whether it be hardwired or wireless. It's going to send a signal to our server saying, is this okay? It will then send a signal back saying, yes, it is. So, and that's where you see the input and the output devices. You can also have door sensors installed at your windows. You can, add different types of technology to your head-end software, temperature control. You can add doorbells and wind chimes, alarms, light sets, all sorts of things whenever you start getting into advanced access control. Right now, we're just talking about the basics. So then you have clients or sites. You could have one client or you could have multiple clients that are controlling the access to these openings, or controlling the temperature, controlling the lights in their office, controlling whether they should sound an alarm or not. So the alternative would be having the same server or ISC, having your network, having your readers and interfaces and lock sets and things like that, having your client, just the same as we had before. But what if we did it wirelessly? Excuse me, I think I jumped ahead, but what if we did it wirelessly without the need of the ISC, by using Wi-Fi technology only, which is what we're going to discuss here in just a little bit. But keep in mind that we can also integrate into our head-end software and integrate in using multiple different types of access control to integrate in, such as video technology. Excuse me for jumping ahead earlier. Using multiple pieces of hardware to be able to integrate into one system will give the client and you the ability to monitor so many different things, which, monitoring your openings, your windows, the temperature, lights, and also who's coming in and out of your facility. We had a project recently, which I'm sure that a lot of you guys have seen, where with COVID, the coronavirus and things, there was a need to control the front of house opening from people coming in and out, preventing them from coming into the facility if they have an elevated temperature. So what they did is installed a video camera at the front of the facility. This video camera tied into the software Aurora, and this video, it takes an image of you, reads your temporal. It has a temporal scanner. If your temperature is above 99 or 100 or whatever you set it at, it will not allow access to your facility. If, however, you're at 98.6 or wherever you set it, it says you're okay, it will allow you to gain access. So different types of integrations, different types of examples of how it could work together. So like I was talking about, and this is why it confused me, so I apologize for that, for jumping ahead. Where was the ISC in that situation? In this solution, it was at the door. That's when we were talking about the wireless software, the wireless lock sets. By using a wireless gateway to be able to communicate with those lock sets, all the technology and things like that is stored at the opening. It creates a situation where you remove some of the hardware that's needed for that opening to work. So, do you guys have any questions before I jump through the second half of this? I know I'm kind of, I'm right on time. Do you guys have any questions for me? Okay, so let's talk about some components. Components of a hardwired system. Like I said earlier, you have to have a power source, which would be a power supply. You have to have a load. You have to have conductors. And then your fifth option would be monitoring. Now, with your power supply or your power source, you can't just plug in 120 VAC and expect lock sets with 22 gauge wire to work, or a door sensor with 22 gauge wire to work, or even a card reader with 22 gauge wire to work. So you have to have a power supply that interrupts that power, or changes that power to 12 or 24 volt AC or DC. You do that by way of a transformer that's located inside this power supply, and also a rectifier. The rectifier changes power from AC to DC. The load, or the lock, you can think of this as your light switch, or excuse me, your light bulb. When the switch flicks on, the light turns on. Same thing with the lock set. When we allow power to the lock, a solenoid either pushes forward or pulls back and allows you to operate the lock to go inside the facility. The conductor, or the wire, is what's dropped to allow all that action to happen. And then the last one, the component, the monitoring, in this example would be the door sensor. So earlier we talked about the power source, and I just went ahead and jumped through, so I didn't have to spend much time on the slide. But a power supply for a hardwired system includes a transformer, which is going to dial down the power or the energy that comes through the system. It's going to have a rectifier that changes the it changes us from VAC to VDC. A filter cleans that electricity up to where you have pure power. Regulator, and then battery backup in the event that you have power loss or something along those lines. If you have any devices that are fail-safe, which we'll talk about later on, battery backup is highly recommended. And then your control boards, which is going to be what's telling, the relays and things that are telling your device yes or no. The conductor, or wire, can look, and it could come in a lot of shapes and sizes, but the main purpose is that it's conducting wire from your frame through your door. In these examples, we have door loops, we have hinges, and then we have electronic power transfers. So as it says in the side, transferring wire from frame to door to the electrified hardware component can be accomplished by a power transfer, electronic hinge or pivot, or a door loop. The switch, or the card reader, or your keypad, is basically what's going to allow you to gain access. The switch can also be just a standard push button that's on a wall, or a request to exit switch, a key switch, a infrared, an active infrared, or a passive infrared. Those all can be switches as well. This switch right here will limit access to an opening. So as I just said, card readers, keypads, or even key switches. Now, other types of switches that allow access but allow egress, which is more important, are your push buttons, or your active infrared, or your passive infrared, which is seen here. So the load performs the work. Some of the examples that are shown here are an electrified hold open device, or a hold open closer, electrified exit devices, or electronic lock sets. Keep in mind that if you're using an electronic exit device, or even some types of electronic locks, you have to check with manufacturer's specifications, because some manufacturers require you to use their power supply with their devices, because power can be regulated, or the inrush power can be so different between manufacturers. They like for you to use their power supply, because it won't void the warranty. So say you're using a Yale device or a Precision device, and you put in one of the most popular power supplies that are out there, an Altronics power supply or a Von Duprin power supply. Because the inrush from those devices is so variable, you could overload your exit device or your solenoid that goes, for your Precision exit device, and void the warranty, on your first use. You didn't think that you did anything wrong because you're using 24 volts DC, but the inrush could have been greater than the device could allow for, voiding the warranty. So keep that in mind when specifying products. You want to stick with the same manufacturer, for your power supplies, for your readers, for your devices. It will allow installation, ease of installation, troubleshooting, and customer service to be a whole lot easier than if you have multiple manufacturers on a job. Electronic hold open closers. What is the need for an electronic hold open closer? Some doors are required to be held open throughout the day or even throughout the night. A prime example of this could be a hotel elevator room where the doors going into the elevator lobby are held open, and you don't want them to be held open via a wall magnet. You want something a little bit more aesthetically pleasing. You would use something along the lines of this. But because those elevator lobby doors are required to be 90-minute or 45-minute, depending on the jurisdiction you're a part of, and because it's fire rated, two of the main rules, or the main rules for fire rated openings, are a door must close and it must latch. So you have to use an electronic hold open closer to allow for that function to happen. So here's another example of a load that's not necessarily a mechanical lock. This is a magnetic lock. There are places where this type of lock set or lock does an excellent job in preventing access. Keep in mind, however, that a mag lock is always fail-safe, and fail-safe basically means that whenever electricity is removed, that the lock is open. So it allows free egress at all times. If you're using a magnetic lock on an exterior entry door, keep in mind that if there's ever the loss of power and you do not have a battery backup or any type of power backup for that opening or for the facility, you will have a facility that is wide open. So what is fail-safe? We just discussed a locking device that defaults to the unlocked state when power is removed. So this doesn't only mean for magnetic locks. If you have exit devices, or if you have, exit device trim that is fail-safe, that means that solenoid, whenever power is activated to that device, the solenoid is what keeps the device locked. As soon as power is removed, the trim is able to turn, and it allows access. Basically turns into passage mode. The same thing with lock sets. If you have a fail-safe lock set, again, you are allowing the facility, when power is removed, to go into passage state, which allows free access. Fail-safe requires a battery backup during power failure for security. And the most important thing is it is the least desirable for security reasons. Fail secure. Yes. So as Naveed just said, there's also fail secure mode. Fail secure is the opposite of fail safe, obviously. And fail secure, what it means is when power is removed, the device goes into the locking state. So it is the most desirable for security reasons. And it's the most desirable, honestly, for your wallet. If an owner has a device that is fail secure, all they have to do whenever they tie in their access control system is add power, via a switch, and the device then unlocks, allowing access. You do not have power going to that lock at all times, basically consuming energy at all times. It's fail-safe is the most non-green solution to your building. Fail-secure, however, would be the opposite of that. When you provide your credential, The switch says, okay, it provides power. You're able to access the facility after 30 seconds, 15 seconds, whatever your potentiometer is set to. Then it will go back to the fail-secure state. Whenever you have a fail-secure lock set, unless you are wanting personnel to gain entry via access control or their key fob, you do not have to have a battery backup, which again saves you money. So, pop quiz time. What are the 4 components of a hardwired system? I'm not going to expect you guys to unmute or even go in with into the chat window to tell me what these are. Hopefully, I drilled these in good enough that you understand that the 4 components are power, load, switch, and wiring conductor. And then the 5th component, which is your bonus question, monitoring. Keep those things in mind, because if you can understand the 4 first ones, the power, the load, the switch, and the conductor, you are able to have the basics of access control. What are some of the code concerns of access control? Let's dig right into those. So, access controlled openings, the entrance doors, and a means of egress in a building with an occupancy in Group A, assembly, education, Group B, M, R2, those are residential, and entrance doors to tenant spaces and occupancies in those same groups are permitted to be equipped with an approved entrance and egress access control system, which shall be installed in accordance with all the following criteria. Must be installed with a sensor. It should have release if there's the loss of power. Manual unlocking, device within 5 feet. Fire alarm system. Sprinkler system, fire detection system, cannot control egress side of Group A, B, E, or M while open to the general public. So the basics of this is, if you are in a facility that has people that are working in it, and if you are, you have to be tied to your fire alarm system, you have to be tied to your alarm system. Keep in mind, you have to allow egress whenever people are wanting to exit the facility. That's the most important thing. Always allow egress out of the facility. With the electromagnet lock, so this is the hard one. Doors and a means of egress that are not otherwise required to have panic hardware, and buildings with an occupancy in Group A, B, E, M, R1, or R2, and doors to tenant spaces in Group A, B, E, M, R1, or R2 shall be permitted to be electronically locked if equipped with listed hardware that incorporates a built-in switch and meets the requirement below. It has an obvious method of operation. So what we're seeing in this example here are 2 electromagnetic lock sets, a door sensor at the top, power supply. But what you're not seeing is where the exit devices are, which in this example, there are no exit devices. These right here, these push bars, are touch sense bars. So they have a switch or relay built into them that as soon as you touch the device, the magnet loses power, which allows you to gain egress. You could also set this up with active infrared or passive infrared at the top. But what you cannot do is that switch, the key switch at the side. In means of egress, which this is another class, so I'm not going to dive too far into it. In any means of egress, you cannot have more than one means of egress out of a facility. So what that means is, if I push the the key switch or the request to exit on the side, and then I want to touch the bar, that's 2 methods of egress. It's not allowed. If, however, you touch the side and the doors automatically open by way of an automatic opener or something along those lines. That is allowed. Or if you push the touchpad or the bar that's there across, if you push that and the door releases and allows you to get out, that is also acceptable. So delayed egress, which always causes a lot of trouble, but you have certain situations, and the most important one is always going to be in care facilities, memory care, and places like that. You're always going to see openings with delayed egress. So let's read this one together. Approved listed delayed egress locks shall be permitted to be installed on doors serving any occupancy except Group A, E, and H occupancies in buildings that are equipped throughout with an automatic sprinkler. Not more than one delay before entering an exit. So if I push the exit on the sign, it's going to say, after 15 seconds, you're going to hear an alarm. Once you start that process, there can't be a secondary process, to start the process. It requires release by a fire detection system, loss of power, signal from fire command, and initiates irreversible alarm. 15-second delay, requires sign within 12 inches, and emergency lighting is required. So just because I'm able to push on that pad and after 15 seconds it's going to open up, that doesn't necessarily mean that there's not going to be a whole lot of people that are going to be coming to ask me what I'm doing leaving through that area. So basically I push on the pad. It says after 15 seconds a sound will alarm. Well, if you have an access control system tied in, it's also going to send a signal to your head-end software saying, hey, somebody's trying to leave through this opening, which is going to trigger a response from your lighting system, and it's going to sound an alarm. Some lights are going to go off. Some bells and whistles are going to happen to where personnel will go over there to find out who just left, or they'll go to the bottom of the stairwell to wait until you get out. Security, so stairwell unlocking. Interior stairway means of egress doors shall be openable from both sides without the use of a key, special knowledge, or effort. There are some exceptions to this rule, especially in hospitals, but check with your local jurisdiction to find out what is possible in your area. So the first example is from IBC 2003. A mechanical door locking is allowed if serving 4 or less stories. Electronic door unlocking is unlocked by fire command. If you have a stairwell that serves 4 or less floors, you are able to limit access to floors 2, 3, and 4, but the bottom floor should be an exit-only device or something along those lines to where somebody can get out of the stairwell. You never want to limit access out of the building. You may not allow people to go into floors 2, 3, and 4, but floor 1 should or must allow egress. Now, on floors 2, 3, and 4, you can say, okay, John wants to enter floor number 2 because he likes walking up the stairs, and Elaine likes to walk up the stairs as well, and she wants to enter floor 3. But how do we do that if we lock those doors? Well, you can add access control to these openings. This example is an electronic strike, and it will allow personnel to access those floors by way of a credential. Now, what you cannot do is buy an electronic strike that is fail safe. If you have an electronic strike, it has to be fail secure because it is a fire door. These are fire rated openings, and because they are fire rated openings, they have to meet those 2 pieces of criteria, which is self-closing and self-latching. So if you are going to use electronic strikes on a stairwell, make sure that you are using Fail Secure. So some of the things to remember from our class today. Different types of access control. The most basic are standalone, hardwired, and wireless. Standalone doesn't necessarily mean that it's battery operated. It could also mean that it's mechanical. The components of access control systems may overlap different divisions. I took out some slides from the presentation because I didn't think that they were necessary for you guys. But always keep in mind whenever you're writing specifications that different divisions can overlap. Division 26 and Division 8 always seem to both supply power supplies, door contacts, and things, and card readers. So please keep in mind that if you're going to be writing them into the security specification, put a note into your door hardware specification that security is taking care of those items. And if you don't want security taking care of those items, do the opposite. Know your codes relating to the access control. These will always affect your access and egress plan. And if you don't know, call an expert. People are always available to you to reach out to and help you in times of difficulties. You know, if you ever need me, please feel free to reach out. I'm always available. We help write specifications. We help advise on specifications and things like that. And more importantly, we love to chat and learn and grow together. So if there's ever a time where you do not know or you need some help with an application or a situation, please reach out and let us know. This is the end of the presentation for you guys. So I truly appreciate everyone who stopped in, joined, and things like that. Keep in mind, sign up for some other classes. Because this one is an AIA class, I cannot offer you any types of gifts or anything like that, but some of the other classes that we have available, we can offer gifts. And what that gift is anybody who signs up and joins any class that is not an AIA class is going to be able to enter to win a Google Home device, which I think we're coming out with some other prizes this year. But for now, we have Google Home devices that we're giving out, and it's a way to thank you guys for participating and joining me. If you want to reach me, please reach out to me at justin@jljonesgroup.com. I will send a follow-up to everyone in this class, telling you thank you for allowing me to teach on this today. I'll put in my contact information so that way you can all give me a call, reach out to me, contact me, call me. JL Jones Group, which is the group that I'm a part of, you can reach out to me anytime. Let me know. If you have any questions, please feel free to reach out. Also, the AIA numbers, send those to me so that way I can write it all down. We can get you a certificate sent back, and we can get those CEU credits to you guys for joining the class. So again, I appreciate you guys joining the class. And from there, if you don't have any questions, I will go ahead and end the meeting.